Hi, today we'll be talking about a very interesting part of mathematics called denesting radicals. So this is a algebraic type of composition, and we're going to it's actually has pretty interesting applications, including a very famous Cambridge application question in which the interviewee was asked to simplify the following. So the question was to simplify this radical. So they had to simplify this radical into the form such as like this a minus plus or minus the square root of b or something like that. So this was the form which was given. And how could one solve this? This actually looks pretty hard. It is actually harder to solve it with the fundamental algebraic things, like if we just do it without knowing what we're trying to do. So in this video, I'll be trying to explain how we can actually perform such a task. So we'll solve that problem at the end after we look at the method. So the question was to simplify this, right? So all questions here are going to be of the form x plus or minus the square root of y. So, and we want to simplify this into the form square root of a plus or minus the square root of b. And this is where we're going to make a few assumptions, like x, y, a, and b are going to be all natural numbers, hopefully positive, and that y is not equal to any constant z squared for z, um, where z is also a positive number. So we definitely do not want that, because that means that y would be a perfect square, and then this would just be a single value. So we want actually a spicy thing. So how can we simplify this? Well, obviously we'd start by squaring this, right? So let's do this in a different color, red. So we're going to square both sides. Seems straightforward. This thing would just come off, and that would come out, and just we're left with x plus or minus the square root of y. And on the other side, it's a little more complicated. We get a, and then anything, if we just have anything, and then we square it either side sign, we're just going to get a positive. And then we're going to do plus or minus, and then this product times 2. So we get 2 times the square root of ab. So this is our equation now. So what can we do here? Well, it doesn't seem pretty obvious at first, but yeah, so we know that like if this thing is not going to be it's not going to cancel out the squares, we cannot get any regular value. So then this is going to be irrational, and this is going to be a rational. So what are the rational ones? So x we already know is going to be a number, and a and b are also going to be numbers. So that means that we can say that because these are the only rational parts and there are no other points in parts of this equation, that means that x is equal to a plus b. And that means that because y is going to be, let's take a different one, green. Okay, so y is going to be the irrational part, so y would be equal to ab. And then that means that if y is negative, there's a negative sign, it's most likely going to be negative. And we can always double check at the end. So this would be a system of equations which we can then solve. And from here, it's pretty easy to solve it. But what if we wanted to find a full formula? We don't want to do any intuitive system of equations. What if we wanted to just find what is A and what is B, and fastly do it fast? Well, we can do that. So let's just rewrite our whole question again. So, I mean, our first starting form. So we have x, the square root of x plus or minus the square root of y, right? And we want to get this into a form, square root of a plus or minus the square root of b. Okay. So what we're going to do here is we're going to multiply both sides by their own conjugate. And we can do this just like if we're squaring it, we're not going to multiply it by one of them on both sides. We're squaring each of them. So we're just going to multiply it by the conjugate. So we can just, let me just erase this thing right here, because it would be part of the same exact one. So we're going to put a parenthesis around this one, and I'm going to use a different color for the conjugate. So the conjugate is going to be x and then minus plus, and then the square root of y. And then we're just going to extend this radical thingy. And then we're going to do the same thing on the other side. Multiply it by its conjugate. So it's going to be pretty much the same idea. We're just multiplying it, and then it's just a minus plus. So now we're just going to combine these things. So in one whole thing, we just get, this is the difference of squares, so we're going to get x squared. And then we can just know what this is going to be a minus, because a plus times a minus is equal to a minus, and a minus times a plus is equal to a minus. So we just get a regular thing here. So let me just rewrite this a little smaller. So we're going to get, so x squared minus, and then the square root of y times the square root of y is just equal to y. So we just get the square root of x squared minus y. And that's the left-hand side. What about the right-hand side? Well, this is also a difference of squares, and by the same way, it's just going to be a minus b. Pretty simple, right? So remember that before we stated that x is equal to a plus b. So we're going to use that same fact here. So we state that, remember, x is equal to a plus b. So that means that b is equal to x minus a, and a is equal to x minus b. That order is a little ridiculous, but it's all right. So let us start in by plugging in b here, so we have everything in terms of a. So we're going to swap stuff to the other sides. So we get a minus x minus a is equal to the square root of x squared minus y, right? So what can we do here? We just get a minus x, and then, so we're just going to plus this, and then this is going to be a plus. So we're going to get 2a minus x, and then equals the square root of x squared minus y. So we're just going to add an x and then divide everything by 2. So in the end, we get the following formula for a. In terms of a, so we get a is equal to 1/2 times x plus the square root of x squared minus y. And we'll see this in action, how it actually works. So what about for b? If we just plug in the same thing, so except we plug in a, so we get a minus b is equal to the square root of x squared minus y, right? And we're going to plug in that a is equal to x minus b. So then we get x minus b equal to the square root of x squared minus y. And then we get x minus 2b is equal to the square root of x squared minus y. And now we're just going to multiply everything by -1, right? -1. So we're multiplying everything by a -1 constant. So then we're going to be able to plus x, because now it's negative on both sides. and then we're going to have a plus 2b, right? So we have a negative square root of x squared minus y, and then we have a plus 2b. So we're just going to divide everything on this thing by 2, and then we just get the following formula for b. So b is equal to 1/2 times x minus, so we have to remember the minus sign, and then the radical, x squared minus y, and then we have the answer. So in the end, we have the following equations in terms of a and b. So a is equal to 1/2 times x minus the square root of x squared minus y, and b is equal to 1/2 times x minus the square root of x squared minus y. And so let's start off the examples by just starting with the Cambridge University interview question. So we're asked to simplify the following. So we have the radical 3 minus the 2 times the square root of 2. And we want to simplify this into without this radical, the whole radical thingy. So we want it in the form of a minus the square root of b. And that's because, well, the square root of a minus the square root of b. So remember, we started off by saying that we can put this into a system of equations where this 3 would be equal to a plus b, and this 2 square root 2 is equal to a times b, right? Well, it would not be, it would just be 2 is equal to a times b, because we're going to divide that by the 2 in the 2ab, the square root of 2ab, right? So, and it's pretty obvious, a equal to 2 and b equal to 1, right? It could be the opposite way, but we're just going to go with this way. And we know that usually a is going to be greater than b. So in this form, we're just going to have the thing is going to be 2 minus the square root of 1. And we can just test this out. So if we were to take the, if we were to square 3 minus, if we were to square this whole thing, we would get that 2 minus the square root of 1 squared, right? We just get that that's equal to 2 plus 1 minus 2 square root 2, and that's equal to 3 minus 2 square root of 2. And that is equal to 3 minus the square root of 3 minus 2 square root 2 all squared. So we have that this is true. Now let us just erase this. And we'll use the new method which we have here with the formulas. So it's the same problem, but we're going to use a different approach just to make sure that this all works. Okay, so we have the problem again. And in this one, we want the form the square root of a minus the square, plus or minus the square root of b. So this is going to be the square root of a minus the square root of b. In the other one, it would just be a minus the square root of b, but this case, we're going to have this other radical. So we know that x is equal to 3, but what is y equal to? In the other one, we had the form x minus plus or minus the square root of y. So we just have to form this into one whole thing, which is equal to the square root of 8. So we just remember this fact. So y is equal to 8. And we have a minus sign, so that means it's going to just be a minus. So a is equal to 1/2 times x, which is 3, plus the square root of 3 squared minus 8 is equal to, and then we can just get that this is equal to 3 plus 1, because this is just 1. So we get 4, and then we divide that by 2, and we get 2. Well, in this case, it would just be that, right? So, and then in the other one, so we get 2 for A. And then what about the other? For B, it would just be 1/2 times 3 minus the square root of 9 minus 8. And we get 3 minus 1, which is equal to 2, divided by 2 is equal to 1. So we get that. And now we're just going to plug in. So we get A is going to be equal to 2. And B is equal to 1. So we just get that this is equal to the square root of 2 minus 1. And so that is the answer, which we got before. So this whole thing works. So I hope you guys enjoyed this video and were able to understand this cool technique. And I hope you guys can maybe use this in your practical life. So thank you guys. Hope you enjoyed it. Have a nice day.